Assalamualaikum and a very good day to my lecturer, Professor Makya T.S. Dr. Muhammad Razali bin Daud. My name is Nurul Sahira binti Radinkar and my ID is TJ25036. So today I will be presenting my failure mode and effect analysis FMEA of an automatic door system. So first, I will explain the system I studied. So an automatic door system is widely used in shopping malls, hospitals, airports, and office buildings. So the system is designed to automatically open and close a door when a person approaches or leaves the entrance. It also operates using sensors that can detect movement or presence, a control unit that processes the signals, and electric motor that drive the door mechanism. And then there are many purposes of the system. So the first purpose is to provide a safe and easy access. It's also improve user convenience and reduce physical contact with the door. It also assists disabled and elderly users. And lastly, it improves the traffic flow in the buildings. Next is the identification of potential failure modes and their effect. So the first component is motion sensor. So the potential failure mode is motion sensor can fail to detect approaching person, and the effect is the doors doesn't open. And then the next component is a door motor. So a door motor, if the motor malfunction, the door cannot open or close properly. And then the third component is the safety sensor. If the safety sensor fails to detect an obstruction, the door may close on a person and cause injury. And then the fourth component is the control unit. And then it is a processing failure can cause the entire system to become inoperative. And then the final component is the power supply. And then the potential failure mode is the power interruption, and the effect it will cause the automatic door to stop functioning. After identifying the failure modes, severity, occurrence, and detection ratings were assigned. Severity measures how serious the consequences of failure are. Occurrences measures how likely the failure is to happen, while detection measures how difficult it is to detect the failure before it causes the problem. So these three ratings are multiplied together to calculate the risk priority number, or we call RPN. So a higher RPN indicate a higher level of risk and a greater need for a corrective action. So based on my FMEA table, the safety sensor failure obtained the highest RPN value of 180. And then the motion sensor failure obtained an RPN value of 140. The control unit failure obtained an RPN value of 135. The door motor failure obtained a RPN value of 128, and lastly, the power supply failure obtained the lowest RPN value of 80. So from this result, the safety sensor failure is identified as the most critical failure mode. This is because the safety sensor is responsible for protecting users from accidents. And if the sensor fails to detect an obstacle, the door may close on a person and resulting in injury. Since this failure directly affects human safety, it receives the highest severity rating. In addition, sensor failures are not always obvious, making them more difficult to detect before an accident occurs. And then the second most critical failure is the motion sensor failure. So with RPN value of 140. So when the motion sensor fails, users may be unable to enter or exit the building conveniently because the door doesn't open automatically. So although this value is less dangerous than a safety sensor failure, it still affects the user accessibility and overall system performance. And then the third one is the control unit failure has an RPN value of 135. So since the control unit acts as the brain of the system, any malfunction can prevent communication between the component and cause complete system shutdown. And then the fourth one is the door motor failure. It has an RPM value of 128, and without a functioning motor, the door cannot move even if all other components are operating correctly. Therefore, motor reliability is important for maintaining continuous operation. And then lastly, the power supply failure has the lowest RPM value, which is 80. And although it is considered the least critical among the identified failure, it can still stop the entire system from functioning. However, power-related problems are generally easier to detect and address compared to other sensor failure. So based on the analysis, several recommendations can be implemented to reduce this risk. So for safety sensor failure, routine inspection and testing should be conducted regularly. And then installing redundant safety sensor can provide an additional layer of protection if one sensor fails. And then the second one is for the motion sensor failure. So for this one, I recommend regular cleaning and calibration because the dust, dirt, and misalignment can reduce sensor accuracy and affect detection performance. And then for door motor failure, preventive maintenance should be scheduled because lubricating moving parts and inspecting mechanical components can reduce wear and extend motor life. Then for control unit failure, such protection device should be installed to protect against electrical disturbance, and software updates and periodic inspection should also be carried out. And then lastly, for power supply failure, an emergency backup or UPS system should be provided to ensure continued operation during power interruption. So by implementing this recommendation, the occurrence of failures can be reduced, and also detection can be improved, and the overall reliability of the system can be increased. So in conclusion, the FMEA analysis has successfully identified the major risks associated with the automatic door system. And among all the failure modes, safety sensor failure has the highest RPM value of 180 and is considered the most critical risk because it directly affects user safety. And then motion sensor failure, control unit failure, and door motor failure also contribute significant risks that can affect system performance and availability. Then although the automatic door system is not completely free from risk, it can be considered generally reliable when proper maintenance practices are implemented. And then regular inspection, preventive maintenance, calibration, and backup safety measures can significantly reduce the likelihood of failures and improve both safety and reliability. So therefore, the automatic door system remain a dependable solution for providing safe, convenient, and efficient access in modern building when maintained correctly. So thank you for your attention. I think that's all from me.